The quest to get our computers to handle the repetitive stuff, the grunt work, it's been a long one.
It really has.
We've seen things like robotic process automation, RPA come along, but let's be honest, they can feel a bit, well, rigid, right?
Oh, definitely. Brittle is the word often used. They break easily with small UI changes.
Exactly. And adapting them is often more hassle than it's worth. Then along came these computer-using agents, CUAs, powered by LLMs.
Seemed like a breakthrough.
It did. Finally, agents that could understand us interact with our desktops. But if we're really honest, their real-world impact, still pretty limited.
That's a very fair assessment. They often have like a superficial grasp of the OS.
Right, their interactions could be fragile, and letting one loose on your actual workstation can feel, well, a little risky.
That's it. The promise is clear, but those limitations operating as a layer on top, rather than being truly integrated, that's held things back. That's the root of the brittleness.
Which brings us neatly to today's deep dive. UFO2, this new AgentOS for Windows automation from Microsoft, it really looks like it could be a significant step forward.
I think so too. From the research, it seems they're tackling that integration problem head on.
Yeah, the papers we've looked at suggest it's all about moving beyond that service level, getting deep system-level integration.
Precisely. And what's really interesting, academically speaking, is that fundamental architectural shift. UFO2 isn't just, adding automation later.
It's built in.
Kind of. It's conceived as this multi-agent agent tossed deeply embedded within Windows itself. That's a huge departure from current CUAs just scraping the GI.
Okay, so our mission today is to really dig into this. We want to unpack the key architectural innovations, the design thinking behind UFO2 that makes it more robust, more efficient.
And focus on the academic significance, the genuinely new ideas here.
Yeah, the research excerpts are quite rigorous. So let's start right there at the foundation, this idea of a multi-agent agentos. What does that actually mean for UFO2?
Okay, so at its core, UFO2 uses a multi-agent setup, basically a team of specialized agents working together.
A team.
Yeah, you've got the host agent and then the app agents. Think of the host agent as the central coordinator. It gets your instruction in plain English.
Like organize these files.
Exactly. It figures out the steps, breaks the task down, and then assigns those smaller jobs to the right app agent.
Oh, okay. So the host agent is like the project manager.
That's a good way to... The app agents are the specialists on the team.
Gotcha.
So there's a dedicated app agent for Word, another for File Explorer, one for your web browser, and so on.
Makes sense.
And what's innovative here academically is that each app agent is tailored for its specific app. It knows the app's quirks, and crucially, it has access to specific APIs for more direct, efficient control.
Not just clicking buttons.
Sometimes clicking buttons, but often, no, it can use the application's own tools. And this modularity is key. You can add support for apps just by building a new app agent. Even third parties could do it.
Wow. Okay, that sounds incredibly flexible. So how do these different agents coordinate? How do they talk to each other to get a bigger job done?
Good question. They use something called a blackboard. It's basically a shared space managed by the host agent.
Like a shared whiteboard.
Exactly like that. The host agent posts task info, status updates, whatever. App agents read what they need and post the results back. It keeps everyone in sync.
Okay, that clarifies the multi-agent part. So instead of just relying on screen reading and fake clicks like older CUAs,
Right.
.UFO2 has these specialized agents with much deeper app knowledge, which leads us to that other big innovation you mentioned, deep OS integration. How does it do that, and why is that such a leap forward academically?
Yeah, this is where it gets really interesting from a research perspective. Most current CUAs, they operate pretty shallowly, right? They look at pixels, they mimic mouse moves and typing.
Like a human, but faster maybe?
Sort of, but without real understanding. UFO2 goes much deeper. It taps into a whole range of Windows APIs. For instance, it uses the Windows UI automation API's UIA. UI automation. It gives the agent structured semantic info about the apps and their UI elements. It doesn't just see a button. It knows it's a button, what it's called, its state.
I guess the underlying structure, not just the visuals.
Precisely. And it also uses native Windows APIs to manage apps launching them, closing them. And maybe the biggest innovation here, the app agents can directly call application-specific APIs when available.
Wow, okay. That feels like a fundamentally different way of interacting. Huge difference.
It is, and that deep OS integration is why it's potentially so much more robust and efficient. It's less likely to get thrown off by small visual changes that would totally confuse a only agent. It relies on the stable underlying structure and those APIs.
That makes total sense, and it links directly to another point from the research, this unified DAPI action layer. It sounds like UFO2 isn't forced to choose between clicking buttons or using APIs. It does both.
Exactly right. The app agents have this hybrid capability. They can do the traditional GI stuff clicks typing, but they can also make direct API calls either to Windows or to the specific app.
And it decides which is better.
Yeah, and that decision process is pretty key academically. If there's an API call that's faster, more reliable, or just, better than simulating 5 clicks in a drag, it'll use the API.
Smart.
And the evaluation data backs this up. The paper shows this hybrid approach leads to significantly higher success rates and fewer steps to get things done. That's a real innovation in efficiency and resilience.
Yeah, why simulate clunky steps if you can just issue one direct command? Makes perfect sense. Much more reliable, too, I'd imagine.
Definitely.
Okay, so even with this deeper understanding, accurately spotting an interaction with the right control on the screen is still crucial, especially with so many different Windows apps out there. How does UFO2 handle that challenge?
Right, good point. And that brings us to their innovative hybrid control detection. They realize that relying only on those UIA APIs might not always be enough. Some apps have custom interfaces, non-standard controls.
Stuff that UIA might not fully expose.
Exactly. So UFO2 cleverly fuses that semantic UIA data with vision-based parsing. They use an advanced vision model, OmniParser-V2. It's called to analyze the screen visually.
So it's using both the structural map from UIA and a visual scan.
Precisely. It combines the UIA understanding with the visual seeing from OmniParser. This fusion gives it a much more reliable and comprehensive grasp of the controls, even on weird or custom interfaces.
That sounds robust, like having blueprints and doing a visual inspection. The paper mentioned this directly tackled control detection failures found in earlier systems, didn't it?
It did, yes. Their analysis showed that just failing to find the right button or field was a major reason tasks failed before. So this hybrid approach was specifically designed to fix that. It's a significant innovation for robustness across diverse apps.
Okay, so UFO2 has this sophisticated architecture, deep OS hooks, the smart GUI action thing, and a solid way to perceive the UI. But, software changes constantly. Interfaces get updated. How does UFO2 keep up? How does it learn and adapt?
That leads to another key innovation, continuous knowledge integration. This is about autonomous improvement.
Okay.
So first, UFO2 can ingest external documents. Think user manuals, help guides.
It reads the manual?
Basically, yes, it processes these docs and puts them into a vector store. It's like a smart library where info is indexed by meaning and not just keywords. So agents can quickly look up how to do something specific in an app.
That's clever.
But it gets better. It also sounds from its own successes. UFO2 analyzes its past execution logs, times when it completed a task correctly.
Okay.
It mines these logs for reusable patterns, examples of what worked, and it stores these examples for something called in-context learning.
Meaning it uses relevant past examples when facing a similar new task.
Exactly. So it's not just static. It learns from external knowledge and its own experience without needing constant retraining from scratch.
Wow. So it gets smarter over time just by doing its job.
That's the idea. This continuous learning helps it overcome what the paper called plan errors, basically, not quite understanding the task or the best way to do it. By pulling in knowledge from docs and past wins, UFO2 gets better and better, a key innovation in autonomous learning.
That's really impressive, a system that improves itself. Now, one thing that often comes up with LLM agents is efficiency. All that back and forth with the language model for every single step, it adds up, right? Latency, cost. How does UFO2 deal with that?
Good question. This is where speculative multi-action execution comes in, another efficiency-boosting innovation.
Speculative execution sounds interesting.
It is. Instead of doing things one step at a time, ask LLM, do step, ask LLM, do next step. UFO2 tries to predict a batch of likely next actions in a single LLM call.
Okay, so guesses the next few steps.
It predicts them based on the current state and goal. But then, and this is crucial, it uses its deep OS integration, especially UIA, to quickly check if those predicted steps are still valid in the current UI state.
So it thinks ahead, tries to run a few steps, but has a quick sanity check built in using those OS hooks.
Exactly. If the UI changed unexpectedly and a predicted step is no longer possible, it stops that speculative batch and replans. But when the predictions are good,
It saves a ton of LLM call.
precisely, it dramatically cuts down the LLM communication overhead. The evaluation showed that significantly reduces the number of steps needed and boosts overall efficiency without hurting the success rate. It's a very clever way to optimize.
That really does sound like an intelligent optimization. Okay, one last innovation that caught my eye, maybe more user-facing. The picture-in-picture interface. What's that about?
Yes, the PyP mode. This is a very practical innovation addressing how disruptive current agents can be.
You mean how they take over your whole screen?
Exactly. UFO2 avoids that. It creates an isolated virtual desktop environment using Windows' own remote desktop protocol looped back onto your machine.
So the agent works in its own little window.
Essentially, yes, a separate contained RDP window displayed right on your screen. The agent does its work inside that Type E window.
Why I can keep doing my own thing on the desktop.
That's the key benefit, concurrent leaser and agent activity. No more having the agent hijack your mouse and keyboard. It makes the whole automation process much less intrusive. A big win for user experience.
That alone sounds like a major improvement for usability. Okay, these all sound like genuinely significant steps forward architecturally. Now, the paper obviously goes into implementation and evaluation. Can you share some highlights there, especially things that really nail down its academic significance?
Absolutely. The implementation itself is quite practical Python for the main logic, C# for the UI, and the Windows-specific bits like PyP. They use a session-based model, which helps with longer, more complex tasks.
Right.
But it's the evaluation that really cements its academic contribution. They tested UFO2 rigorously on two standard, quite challenging Windows automation benchmarks, WAA and OS World W.
Windows Agent Arena and OS World Windows. Okay, and how did it do?
The results were pretty clear. UFO2, especially when paired with top LLMs like GPT-4o or the latest O1 model,
Yeah.
achieved significantly higher success rates than the previous state-of-the-art CUAs like Operator, often by a really wide margin on both benchmarks.
Wow.
And they quantified the impact of speculative execution, showing it really did cut down the average completion steps needed.
So it wasn't just faster, it was more successful too.
Exactly. And interestingly, they broke down performance by app type. It did really well in web browsers, coding environments, and the analysis showed how that deep OS integration and API availability in apps like Microsoft 365 really boosted performance compared to, say, LibreOffice, which has less API support.
So that deep integration isn't just theory, directly translates to better performance in apps that support it well.
That's what the data strongly suggest. And their error analysis was also academically rigorous. As we mentioned, they categorized failures, plan errors, execution errors, control detection failures.
Right.
And that analysis directly fed back into the design. For example, seeing lots of control detection failures is why they developed the hybrid vision UIA system.
So they identified the specific weaknesses and built solutions for them. Did they prove those solutions worked individually?
They did. Through meticulous ablation studies, that's where you disable one component at a time to see its specific impact.
Okay.
These studies showed, for instance, that hybrid control detection significantly improved success rates and the ability to recover from detection errors. The GUI plus API integration boosted success and cut execution errors. Continuous knowledge integration improved success and reduced planning mistakes. And speculative execution demonstrably cut down the number of steps.
So they systematically validated each core innovation. Strong evidence.
Very strong. And they even touched on this everything as an agent idea.
Right, showing you could plug other agents into UFO2.
Exactly. They showed how an existing agent, operator, could function as an app agent within UFO2's framework. Really highlights the extensibility.
Makes sense. And did they find any bottlenecks?
Yes, the main one, unsurprisingly, was LLM inference latency. That thinking time for the language model is still the biggest factor slowing things down, which is common across most LLM-powered systems right now.
Okay, so UFO2 is a big leap, but they're still looking ahead. What future directions did the research mention?
Well, tackling that LLM latency is key. They specifically mentioned exploring smaller, specialized language models, LLMs, lightweight language models, maybe optimized for speed in these automation tasks.
Faster, more focused models. Makes sense. Anything else?
The other big one is generalization. UFO2 is Windows focused now, but its design, especially using those accessibility APIs like UIA,
That might translate to other operating systems.
potentially yes. They mentioned Linux and macOS as targets, leveraging their accessibility frameworks. That would be huge.
A cross-platform AgentOS. Wow. Okay, stepping back, in the bigger academic picture, where does UFO2 fit? What's its main contribution?
I think UFO2 marks a really significant shift. It moves us away from early, maybe more conceptual CUAs towards practical, deeply OS integrated solutions. Call them AgentOS, maybe.
Like AOS or AutoOS concepts we're starting to hear about?
Exactly. It aligns perfectly with that emerging research trend of weaving LLMs right into the OS fabric. UFO2 provides a concrete, working, rigorously evaluated example of how you can do that effectively for desktop automation.
So it's proof of concept, but much more than that.
Right. It shows that by ditching the shallow GUI scraping and embedding agents deeply, you unlock real gains in robustness, efficiency, and user experience. It significantly advances the academic understanding of how to build these intelligent agent systems.
So wrapping up, it really feels like UFO2 isn't just, another small improvement. It's a fundamental rethink, focusing on that deep OS integration and a cluster of really novel architectural ideas.
Absolutely. The multi-agent system, the hybrid actions and detection, the continuous learning, the speculative execution, it all adds up to something demonstrably more powerful and efficient than what came before.
And the potential impact on our productivity, our user experience. It could be massive. Imagine systems that just get what you need done and handle complex workflows without constantly interrupting you.
It's a very compelling vision for the future of how we use computers. And, considering the level of OS integration UFO2 achieves, it really makes you think.
Yeah.
Well, it poses a fascinating question for you, for all of us, really. What are the long-term implications here? How might this change how we interact with computers? Could it even change the definition of an operating system itself?
From just a platform to an intelligent partner.
Maybe an OF that's not just passive, but actively understands and automates our digital tasks at a much deeper level. We could be right on the edge of that shift. It'll be fascinating to watch. And for anyone listening who wants to dive deeper, the UFO2 paper and the code are actually out there publicly available.